Assalamualaikum warahmatullahi wabarakatuh. So let's move to subtopic 3.7. We have electrical energy and power. So in this subtopic, we're going to discuss the relation between energy and also power. So how does energy relate with power? So there is one formula that relates with these two quantity. Okay, so energy usually relate with work done to move a charge from one point to another point. So power also, the definition for power, it should be the rate of energy or rate of work done. So it should be related to one another. So let's just focus to the diagram in the notes. So we have a battery that is connected to one electrical device. So boleh imagine apa-apa saja device yang kita connect. Contohnya resistors ke, bulb ke, whatsoever. Okay, so apa yang jadi dekat sini bila ada electrical device. Okay, so let's just assume kita forget about internal resistance of the battery. So kalau ada satu device, bermaksud voltage ni amount dia sama dengan voltage across battery. Okay, so let's just ignore the internal resistance first. Okay, so actually kalau ada current flow, okay, dalam case ni current flow from positive terminal to the negative terminal. So this is the direction of current from positive to negative. Okay, dalam case ni dia akan bergerak daripada A kepada B across the device. So kita ada formula that relates current and charge flow. Okay, so Q equals to IT from the definition of current, which is rate flow of charge. Okay, so kalau current move from positive to negative, charge akan flow from negative terminal to positive terminal. So that is the direction of charge. So kita ada Q equals to IT. And then, so in order for the charge to move, dalam case ni, dia akan jadi, the charge will be moving from B to A. So it requires work. Okay, so formula daripada chapter 1 sebenarnya, work done equals to QV, ataupun daripada formula electric potential, V equals to work done to move a test charge kan, work done over Q. So dia adalah formula yang sama. So daripada formula ini, to move a charge from point B to point A, kita perlukan this amount of work done that relates with voltage of the battery. So ini adalah voltage of the battery yang kita label as V. That is also equivalent to voltage of the device, voltage across the device. So daripada formula ni, we can substitute Q equals to IT in this formula. So end up kita akan dapat W equals to ITV. Okay, so basically the same formula that I've stated here. W equals to IVT. Okay, so formula ini adalah untuk kira work done associated with current flow yang kita relate dengan charge flow tadi, dan voltage of the battery. So dalam case ni voltage of the battery also equivalent to voltage of the electrical device, dan juga time taken for the current ataupun charge flow from point B to point A. Okay, so dia mesti relate to one another lah. So that is work done in terms of current and voltage, also time lah. Okay, so that is actually electrical energy yang kita nak discusskan. As simple as that. So itu adalah energy, iaitu work done to move a charge from one point to another point. So next kita nak fokus kepada electrical power. Power pula, the symbol is P. Okay, so macam mana power, formula power boleh keluar daripada formula W equals to IVT. Okay, so kita pergi kepada definition of power. So actually kita dah belajar daripada semester 1 lagi, power is actually defined as work done or energy per unit time. So dia mesti W over T. So energy liberated to the device ataupun energy dissipated from the device per unit time. So formula dia mesti ini. Ini ada definition of power, W over T. Dan kita masukkan daripada formula IVT dekat atas tadi, kita masukkan, kita substitute work done equals to IVT. So end up, kita boleh cancel out the T. So dapatlah satu formula yang famous, iaitu P equals to IV. So daripada sini, kita derive satu formula, P equals to IV. Okay, so this is the main formula to calculate the power. Tapi kita tengoklah, kalau kita nak cari power dissipated through the device, so voltage ni mesti voltage through the device lah. Voltage across the device. So kena faham lah. Okay, so that's why kat sini dispecifickan in electrical device. So mesti related. Kalau power relate to electrical device yang mana? Kalau satu saja device, so voltage yang kita akan consider adalah voltage across the device juga. Okay, so kena clear dari segi formula. Bukan simply ambil saja mana-mana voltage dekat dalam circuit tu. Okay, so kadang-kadang ada juga soalan diminta power loss through resistor or any other device. So sebenarnya dalam circuit, kalau ada satu-satu device seperti resistor, seperti mentol, apa-apa sahaja, so bila dia connect dalam circuit, apa yang akan terjadi adalah sebenarnya terdapat sedikit power loss. Okay, terdapat power loss through that device. Okay, so macam mana nak kira power loss ini? Power loss ataupun power dissipated. Okay, kadang-kadang ada term digunakan power dissipated through the device. So kita, macam saya cakap tadi, kita boleh guna formula ini. So as long as kita tahu V ni adalah across R ataupun across device yang kita tengah cari power dia. Okay, ataupun kita boleh gunakan substitute V ni dengan formula Ohm's law, V equals to IR. So kita dapat another formula P equals to I square R. So ini adalah resistor. Make sure resistor device yang mana. So berapa resistance bagi device tersebut. Jadi kita akan dapat power yang relate kepada resistance ini. Okay, ataupun kita boleh gunakan substitute, gantikan I dengan V over R. So kita dapat another formula V square over R. Okay, so benda yang sama juga. Make sure voltage yang mana yang kita kena consider dan resistor yang mana yang kita kena consider. Supaya kita boleh menjawab soalan tu diminta power untuk resistor yang mana. So basically daripada ketiga-tiga formula ni hanya dua formula sahaja yang kita kena tahu. P equals to IV and V equals to IR, which is Ohm's law. So kita boleh derive lagi dua formula yang di sebelah sini daripada equation ini. Alright. So kita tengok example 9 here. So example 9, a light bulb has a rating of 230 volt and 60 watt. So dia bagi nilai power of the bulb and voltage of the bulb. That is the power rating. Power rating usually consists of power of the bulb and also the maximum voltage that the bulb can stand. Okay, so dia bagi nilai power dan juga nilai voltage. And then calculate the quantity of charge that passes through the bulb in 3 seconds. So that is time. Dia minta charge. Okay, dia bukan minta number of charge. Dia minta the quantity of charge. Bukan dia minta number of electron, tetapi quantity of charge. Okay, so dia minta Q sebenarnya. So basically, daripada famous formula of power, P equals to IV, you can actually figure out what is the current flow. Okay, by substituting the power value and the voltage value. So from here, you can calculate the current. And how to calculate Q when we have current punya value. Okay, so we have Q equals to IT because time is given. Alright, so as simple as substitutekan current yang kita baru dapat tadi dan time yang diberi dalam soalan. So you can calculate, you can figure out what is Q here in coulomb. Okay, so mungkin confuse kat sini lah sama ada ini adalah number of electron ke sebenarnya number of coulomb. Okay, so quantity of charge refer to Q sebenarnya. Okay, bukannya number of charge tapi dia adalah Q, coulomb. Alright, so that's all for 3.7 actually. So as simple sahaja, so boleh siapkan tutorial. Alright, thank you.